My name is Carsten Maas. I'm Customer Success and Training Engineer EMEA at Kerio. Also, Martin Medunas today joining, who is responsible for the security for our cloud operations. What can you expect today? Today, we are going to talk about the Samepage structure. We are going to talk about Samepage security. I would like to cover some typical questions we have heard in the past, and I will want to give you a quick example how data is flowing through the internet, which is, I think, pretty interesting for you. So first, let us start with the Samepage structure. First of all, everybody knows maybe Workspace. Samepage has a complete new structure. First of all, we have web servers. Web servers are basically covering the normal process when you come to the Samepage page or the Samepage web page. We also have another machine, or even more machines, which are called the registrators. These machines are responsible for the registration process when you register at the Samepage. We have, of course, a mail server, or more a bunch of mail servers, which are responsible for the whole mail communication. So, for example, when you're following a page and somebody is writing a comment on it, this will initiate a mail, and this will be handled by mail servers. We then have the application servers. Those application servers are basically responsible for the components you are using on Samepage, like the text component, the video component, the table component, etc., etc. Additionally, we have search units. Those search units are responsible whenever you do a search in Samepage. These search units are responsible to give you the results for any search. We have database units. In the database units are basically stored the users. So every user who has registered at Samepage and also the organization information are stored in those database units. Additionally, we have the Swift file store. In this Swift file store, all your data is stored, like when you upload a PowerPoint file, when you upload a video, whatever kind of data you are uploading, this will be stored in the Swift file store. To have those bunch of servers monitored and controlled, we have the so-called Zookeeper ensemble. Those Zookeeper ensemble will be responsible for monitoring all those different servers and also maintaining those different servers. Of course, again, as we already have a huge user base already using Samepage, to prevent problems when accessing your Samepage organization, there are load balancers which are responsible for, as the name says, balancing the loads of requests coming to our Samepage cloud. In this brief overview, you see how they are interconnected and how data is pushed and pulled between the different servers. Is it correct so far, Martin, or would you like to add something?
Yes, it's correct, and I think you explain it enough. So I don't want to add anymore.
Yeah, I think it's not necessary to go into much more detail as we see what concerning security issues. This will be covered in the next slides. Okay, perfect. So let's do a Samepage structure recap. We have various machines for various tasks. This guarantees us a high availability. We have a very high redundancy concerning those machines, which gives us the freedom of deployment. What do I mean with freedom of deployment? Because of the reason we have different machines and different servers hosting our Samepage cloud, it gives us the ability, for example, just to update an organization. Let's say it's a Kerio internal organization, to update this with a new version so we can test it before it will be released to the public. So as it was always in the past, Kerio employees are the guinea pigs for our products. So with this new structure, it is easy for us just to update one instance, one organization, and the other organizations will not be touched. This gives us, again, the possibility to test everything, maybe to incorporate new functionalities. And when something happens, it happens only to this organization and not to the others. And of course, you see, we have no flat file structure anymore. When you remember the times when we had Workspace, everything was in one directory. You had a directory which was called Workspace, and all files have been inside this directory. As you can see, or when you remember my slide where I showed you the structure, you could see that you do not have such a flat file structure anymore. Everything is on various and different machines. Again, this gives us the possibility to update things really quickly and to test things without harming other organizations if something went wrong. Let's go over now to the security. First of all, let's talk about users, data, and security. The connection to our Samepage cloud is, of course, SSL encrypted. By the way, our Samepage cloud was not affected by the Heartbleed, as we have this OpenSSL bug figured out really, really quick, and everything was safe. But we, as you may have recognized, you have been encouraged to change your user password after this Heartbleed thing was mentioned in the press. This was for precaution. We have strict HTTPS connections, and we are using PFS, Perfect Forward Secrecy. Of course, before you can log in, everything is protected by a password. And even more interesting, the content is isolated from other content. So let's say the content from organization A is isolated from the content of organization B. And as I have already told Martin, as everybody would maybe wants to know, what is perfect forward secrecy? And this is what I have told Martin before. Martin, can you please shed some light on this? What is a perfect forward secrecy?
Perfect forward secrecy is a technique how to protect the communication on each session on which different password or different secrecy, different encryption key. The traditional TLS or SSL connection derive the encryption key for encrypting each SSL session from master key, which is same for certificate. It is actually not very secure when the private key of the server is compromised. Of course, it is not very easy to compromise private key of the server, but as we recently saw in a hardware vulnerability, it is possible. To if you have a private key of the server, you are able to, in the future, to unencrypt all future connection to the server without perfect forward secrecy. It is possible, but if you use a perfect forward secrecy, it is not possible, because each SSL session has a new encryption key, which is not derived from the master key of the server. It's used Diffie-Hellman algorithm to key exchange. Maybe you are familiar with the algorithm, and it is not very new. It's quite old technique, and but it is not commonly used today. I think Google starts supported massively in their servers, and I think they push forward the OpenSSL library to for better support of forward secrecy. By the way, today the most browsers support it, so there is no reason why not use it in the server side. But if you can see, you'll find a lot of servers which is not supporting this technique. Samepage do it, and it allows us to improve the whole security communication between the client and our servers. That's in the short.
Okay, so basically, to recap, PFS means that it is a session-based certificate, which means even if somebody will sniff this secrecy, for the next session, it's a complete new one, so he can't do anything with it.
Yes, you're right, but this is partially right. It is right in the traditional SSL, of course, too. But in the traditional approach, is that the secrecy or the key is derived from the master key of the server. So the source is always same. So if you hold the master key, you are able to decrypt all derive keys from this communication. In PFS is independent of the master key, so it's always randomly generated. That's the basic.
Perfect. Perfect. On one of the next slides, and I think if you would like, this presentation will also be stored in our partner portal. So even if we have today some attendees which are not registered to the partner portal, as they are maybe end users, as this presentation is also for end users, please contact your Kerio reseller or our Kerio partner, and he will be happy to offer you a copy of this presentation. So I will just go on. Next topic would be the connection itself, network and security. What I think is pretty important to know is that it is our own infrastructure of servers. There are no third-party servers. For example, when you look at Dropbox, they use the Amazon S3 servers, which is not bad. It's perfect. It's okay. But it's not in the hand of Dropbox. With Samepage, those servers are our own servers. So we are not booking any servers at Amazon or whoever. It's our hardware. It's our servers and our infrastructure. Samepage generated mails are using the common security options. Of course, this is a Kerio Connect behind with anti-phishing, DKIM, SPF, etc. Of course, we have firewall systems protecting us against possible attacks. The next slide will deal about the data, backup and security. All our systems are redundant. So even if one server fails, this is not a problem at all, as we have them multiple times. We have redundant load balancing systems, and we keep at least 3 copies of all data. Which does not mean when you delete something that you can call one of our Samepage ops and say, "Oh, I have deleted some data. Please, can you restore it from a backup?" This is not the case. We are not going to restore things for you, but you can be sure that we have at least 3 copies of all data. And what is also new, encrypted data center links. And maybe Martin, you can help me here again a little bit. What does it mean when we say we have encrypted data center links?
Of course, sometimes we need to transfer data between the systems. So all the data, all the links are encrypted. Usually we use SSL. So if there will be any attacker who can potentially listen the communication, he's not able to recover any data, because all the communication is always encrypted. So that's all.
Okay.
Very simple.
Perfect. Okay, simple but very useful.
Very important, of course.
Okay, and important, of course. As we have already mentioned, the data center, high availability and security. So we are 24/7, 365 days a year. We are monitoring all of the hardware and all of the services. So in case something went wrong, we will be alerted, and somebody from our team will take care about it. The data center itself, if you want to enter it, we have biometric entrance control systems. So only people who have given their biometric information will be able to enter this data center. The data center itself is SSAE 16 Type 2 compliance certified. If you need to have further information about this certificate, you can look it up at the website I'm mentioning in the lower right corner. It's SSAE-16.com. Of course, this data center is protected against flood, fire, etc. And all of those high availability and security things we can guarantee approximately an availability of 99.99%. Before I open a chat for questions, I would like to cover some typical questions we are faced with. So first of all, a typical question would be, what is a tier 3 data center? Believe me, a tier 3 data center means that it is guaranteeing a high availability and some security prerequisites. If you would like to have further information on this, please have a look at the Wikipedia article. Let's say a typical tier 1 data center is not protected, nothing is redundant, etc. So tier 3, I think the next higher level is tier 4, and that's it. There comes nothing higher. Will there be European data centers? It is planned, but we have no time frame yet. And why a European data center would not have been so interesting, I will show you after this slide. Is your data encrypted? Of course, the connection itself is SSL encrypted and we use PFS. Again, you can have a look at the Wikipedia where this forward secrecy thing is perfectly explained. The data itself, so when you uploading a file or something, needs to be encrypted by the user himself before you transfer it to Samepage. Is Samepage planned as an on-prem solution? As you have seen, due to the complex infrastructure, for example, various servers, it cannot be released on-prem. So what do we do against Echelon, NSA, GCHQ, etc.? We have complete control over the infrastructure as it is our own infrastructure, but to be honest, we do not have control about the data, how it flows. And this is maybe an example which can help you and will maybe also help you understand why a European data center would not be necessary. So I give you a quick example. I've taken this example from a presentation. Linus Neumann, a pretty smart guy. He was also in some committee for our government when it comes to the email. This was is an example out of his presentation, Bullshit Made in Germany. It was a presentation he has done at the 30th Chaos Computer Club conference. Everybody who wants to view the whole presentation of Linus Neumann, there is a link. Just search in Google for Bullshit Made in Germany. I have taken out this example. So how does data flow? Example for Germany. In Germany, we have a pretty big backbone. Backbone means this is some sort, let's say, data center where basically all of your communication is going through. This is a DE-CIX or D6, which is based here in Frankfurt, where I live. But we also have a second big backbone here in Germany, and this is driven by the German Telekom. So what do you think would be the best approach if I want to send, let's say, an email to a guy who is connected to the German Telekom backbone, and I am connected to the DE-CX backbone? Wouldn't it make sense that those two backbones are exchanging the data directly? Of course, but this is not how it works. The reason is the German telecom backbone and the DECX are not so much interconnected to each other, because if you want to interconnect those two backbones, of course DE6 says, okay, telecom, please pay me some money so you can hook up your line directly to my backbone. And also vice versa. The German telecom says, okay, DECIX, if you want to connect to my backbone, please pay me some money. So what does it mean for the end user? First, there is another big backbone based in the US, and it's driven by level 3 communications. So to give you now an idea how a mail would flow through the German telecom backbone, it goes from the DECIX to the level 3 backbone in the US. From there, it goes back to the German telecom backbone. And maybe you already get the idea what now could happen. Exactly. The communication between USA and Germany can be sniffed somehow by the National Security Agency. So even if you have a data center based in Europe or based in Germany, you can't prevent the data that it won't go over the US. So the question is, do we really need a European data center at all if we can't prevent data from flowing overseas and back to Germany? I just would like to give you another example, which I made a test this morning. I made a simple trace route to an internet page. The internet page is naonis.com. So Naonis is based in Italy, and I'm based in Frankfurt. So the ideal communication would be that it goes directly from Frankfurt down to the server of Naonis. But guess what? The data flows like this. When you do a trace route, you can easily see the different hops your packages are doing. And then I saw an IP, and it was 130.117.125. And it is an IP which gives me the host cogentco.com. So I was wondering, okay, who is cogentco.com? So I searched this for this IP, and what do I see? This IP is based in the US. And then it goes forward to the Italian server. So even I'm sitting here in Germany with a German telecom internet connection. My data first flies over first to the US and then to Italy, and not directly to Italy. You say data should be encrypted. How should that be done? You mean, Anton, for example, you have a file and you're going to upload it, and you're going to upload the data, the file to a Samepage page, correct? Or text. You can do a search for, there are various encryption tools you can install on your Windows machine, on your Mac. For example, on a Mac, you can very easily make some, let's say, some sort of image which can be encrypted. This works then like a hard disk, so you can put your files you would like to upload there in this disk image, which is encrypted, and this image you can upload to Samepage, and you give the decryption password to somebody else, to the person who wants to download and decrypt the file. So there are various tools and stuff how you can encrypt something. As I said, we cannot. How should we encrypt data on your local machine? That can't be done. This lies in the responsibility of every user. Any other questions?
I can answer to Vincent.
Perfect.
Actually, we are planning the encryption on our servers. I can't say you exactly how it will be done, but there's a plan to encrypt data in REST. I think details will be published when we will be done. So yes, we will do that. But I don't know if it will perfectly fit what you wait. But we will do that.
And the second question from Anton, and please correct me, Martin, if I'm wrong, is an Kerio administrator able to access the data? I can say no. Simple no. I do not think that Martin, are you able to access specific data from Anton when he has something on Samepage? I don't think so.
No, it's very complicated. Complicated but possible, but of course monitored.
Vincent is asking, you said you won't restore data from backup. Do you plan to provide undelete feature? You always have your, please correct me, Martin, if I'm wrong, but I have this trash icon on Samepage. So when I delete something, I can look up in my own trash on the same page, correct?
Yes, you are correct.
So this has not changed. Or do you mean, Vincent, when you have maybe deleted your whole organization? Is a sync client syncing encrypted data?
Of course, it is.
You mean when you put something? Of course. Of course. Question, but can a site admin, you mean the content when you are a content admin, or what do you mean? I believe the trash is user based, correct?
Yes, I think so. I do not use it regularly, so I think so. The admin are not able to restore user data.
Yep. My fellow Marino Vigiliotti, which is our SE in UK, will just jump in. He would like to answer this question. Marino, go ahead.
Yes. Hi, everyone. My name is Marino Vigiliotti. I'm a sales engineer. Thank you for introducing me, Carsten. Regarding the undelete feature, that is done at organizational level, but also depending on the rights of the person. So if I'm actually a reader or contributor to that page, I do not have the rights to undelete it. So effectively, that is even more granular. If you are the owner of the organization, of the page, you should be able to restore what you've been doing. And we can go in a little bit more in details. This is about the functionality and the features inside the page. So the undelete is actually related not just to the organization, but also the rights as a user that you've been associated with. However, there is a bigger, higher level, which is a content administrator, and that has a much higher level that can undelete. So it's all managed by organization and users within the company. Thank you.
Perfect. So Vincent is. This is a feature where we have some votes on it. We are thinking about it, but sorry, Vincent, we do not have a time frame for that. Okay. Okay, Vincent, one last question. As I said, if some questions are maybe not covered enough, please contact your sales representative, or if you're an end user, contact your Kerio reseller, and they will be happy to forward the questions to us.